Okay.
Arun sir, we can start the session now.
Okay. Oh, hello everyone. Let's start today's session. As like yesterday, we have discussed about Q, some difficult programs of Q also. We have also seen some examples of recursions. At the same time, we have seen the concept of backtracking as well. So these were also like very important topics which play a crucial role in your IT career, right? So let's start today with a new data structure that is very familiar to all, and that data structure is tree, right? You must have all have heard about so many things about tree. Why do we use tree data structure, and how it is implemented, and why should we use the tree data structure, and when should we use the data structure? That's also an important question, right? So while considering all those things, we should know that first of all we should know what is tree. As we all know, that tree is a non-linear data structure. That means you can traverse in more than one direction, first of all. Secondly, it works on a hierarchical basis, or you can say on a level basis, right? For an example, in your college itself, you can say there is a vice VC, and there you can say there is a direct principal. And under this you can say there is a dean, and then the faculties and all. So these levels can be easily represented by the data structure like tree, right? So what we need to understand is that whenever we have to implement the data which is in the structural form, which is in the hierarchical form, you can say, or which is divided level wise, in that sort of case you can simply implement the tree data structure, right? So the first, I will be letting you know about basic terms about the tree, basic terminologies about the tree, so that you can get the idea how the tree works, right? Some of you might be having the knowledge earlier, like that how tree works basically, but we will go from very basic to advanced, and we will also implement the tree practically also, don't worry, right? So let's try to understand the tree first. So you can say, suppose, let me explain you very clearly. So this is a tree, basic a tree data structures, in which we need to know a few of the terms, right? And what are the terms which we consider like while go for tree, right? So let me tell you, we all know this is the start of the tree and foremost, and this is called root. The root is the main node, you can say, right? Main node of the tree, main node you can say, from which other nodes, other root, other parts of the tree are coming, right? So this is the first most starting node in a tree. What term I'm using over here is node. So what is a node? Node you can say represent as a structure, a data structure, which has data, and you can say and the pointers as well, right? Right. So this is a root node, and this is a child. So B and C are child of A, and at the same time I can say D is the child of B, D and E are the child of B, and at the same time you can say F and G are the child of C. This goes like this, right? This goes like this, right? So what we need to understand that each how these terms are related to each other, how the nodes are related to each other, so that we can go further. So this is also a child. These both are what siblings we say, right? All these nodes who don't have child, we can say we can term those nodes as leaf node. Leaf node is what? Who doesn't have any child, right? We can consider these nodes a leaf child, right? Clear? Hopefully it is clear to everyone. If you find any difficulty in understanding, please you can just simply ask in the comments also. Right? Okay. So now one more thing I would like to tell you that these are the levels. The root is at 0 level, 1 level, and the second level. Right? So these are the levels of the tree: 0, 1, 2. The 2 is the highest level, and we can also say the 2 is the height of the tree as well, right? And I one more thing that any part of tree, any part of tree is also considered as subtree. Any part of tree is considered as subtree. Avinash sir, I think is there any lagging from? Am I audible to all? Please comment in yes, every student.
No, sir. Carry on, please.
Yes, sir. Right. So basically, what we are learning. So we have just seen an example of subtree. Now again, we will be
Sir,
going
we
to
have kept the chat on hold right now, and we will open it in
no
the
issue.
query sessions.
Okay, so no issue. Please check whether the streaming is lagging or not. Right. So as we can see, the part of the tree can be considered as subtree. So wherever you are going to like read about tree, these are the basic terms which you definitely need to know how the terms are related to the tree. Right. They are the basic terms. You can easily say like, right. So now let's move further. Types of tree. Let's try to understand the types of tree. First, very example you will find of tree that's binary. As the term suggests, binary means two. So a tree which can have maximum two childs is considered as a binary tree. This is a simple example of binary tree: A, B, and C. Right. So this is a simple example of binary tree. Right. How it will work. Right. Just a second. Right. So this simple example binary tree. Now, any tree which is not having more than two child can be considered as a binary tree, right? And a tree, there's a binary tree also. There's like another tree like you can consider. Wait. So this is a binary tree having two child, right? You can also have binary search tree. Binary search tree has other properties as well, like Binary search tree states that if a root node is there, then the value of root node will be greater than the left child and will be lesser than the right child. So A is the root node, B is the left child, C is the right child. For example, it is having a value 10. So the value of B node cannot be greater than the 10, right? It always be less than 10. 15, sorry, 9 and 8 is 15, right? So this is an example of binary search tree. Binary search tree is a special kind of binary tree which states that the root node, the value of root node will always be greater than the left child and will always be less than the right child, right? This is about the binary tree. You will see all other trees also, that B tree, B plus tree. These three are used for the databases as well. You must have heard about AVL trees also. AVL trees are the what are the these are the just balanced binary trees. Binary search tree, sorry. These are what? These are the balanced binary search tree, and these are considered as AVL, right? These are the AVL tree. AVL tree are balanced binary search. So these are the like few types of the binary tree which you can consider. There are other types of tree also, like ternary tree also. You can say these are ternary tree. The trees which are not binary tree, or you can say the trees which are having more than two child can be considered ternary tree also, right? You can also see amary tree. So many types of tree are there, right? Right. And one more concept you must have heard about. This is a very new concept. The trie is a special kind of tree which is used to maintain the dictionary, right? So this is also one of the concepts which we can see easily in the tree data structure, right? So these are the few things which we have come up through the tree. Now let's try to understand the basic operations which we can perform on the tree, right? So let's try to understand. Hopefully you have seen this. Right. So now let's try to understand what are the basic operations which we can perform using tree, right? First, initially we are going through the conceptual concepts. Then we definitely will be implementing to the code also. And now today I will also let you know how to implement a tree with the C. We will also see some code in the C. We will also see some code in C++ and in Java itself. I'll mix the code so that you can understand that language is not a barrier. It all about making the logic and understanding the concepts, right? So now what I was saying, that what are the operations in the tree, right? So the operations in the tree, you can see the operations in the tree are insertion. Operation in the, you can say BST, binary search tree. Insertion, deletion, and traversing, searching, you can say. Last one is the traversing. So these are the few things, few operations which we can find. Traversing is a very important part in BST. In each and every, most of the your exams, or you can say most of the in your data structure interview questions, you can find the question of traversing also. You all must be knowing about like the the period of post. And but the only point is that, have you ever implemented this in using your algo? Have you ever made some kind of algo for the same? Have you ever implemented that algo in any of the programming language? That also depends, right? And you also need to know what are the complexities of these operations also. These are those also play a pivot role. Specifically, what are the complexities while traversing the nodes of the tree, right? These also some few important things which you need to consider, like while performing an algorithm, or you can say while performing an operation, right? So let's move further, right? Okay. So first of all, we need to understand these are the operations which we can perform. But before this, how do we make a binary search tree? That also we need to understand, right? How do we make a binary search tree? That also we need to understand. So I'm taking a basic example uh, to illustrate you how you can make. Suppose you have given with some nodes, you are given with some data, and then how you can make a binary search tree out of those data, right? Or you can say from those data, है ना? So let me tell you. So let's try to understand few things. Suppose I am given with the data 18, 14, 24, 6, 19, 23, and 16. Suppose I'm given you the data, and straight away I have to form a BST, that is binary search tree. What I can do? I use simply the first data, the first value given to me is considered as the root node. So I'll make this 18 as a root node, and the left part, the 14 is the left. Since see, compare, 18 is the root node, and in the BST, what I told you earlier, the root node, any child and the child, any value that is smaller than the root node will go to the left part, left side, left subtree, you can say, and any value greater than the root node will go to the right subtree. That we know, right? So 14 will go to the left, 24 is greater than the 18. Now again, 6 is smaller than the 18, smaller than the 14, and it will straight away go to the 14. 6 at 19, it is greater than the 18 but smaller than the 24. 23, it is greater than the 18 but smaller than the 24 but greater than the 19, and straight away will go to the right to the 20. 16, it is smaller than the 18, greater than the 14, then it will. So I have simply made a BST on the basis of data given to me, right? Right. Suppose, please think, if I give you data, try to make make a BSC out of this data. You can take a screenshot in the last query section. I will ask you to represent to show your show your BST based of these data. So please take a screenshot of this, that how you will make the BST out of this data. Got it? This is the first example. This is the example I took, and I also requested you that if you can also make the same, right? And one more thing I would like to tell you, that how it works, how a tree structure basically works, right? You need to understand one important thing, that let me tell you. Once you're done with this understanding part, then it will be easy for you to code and to make the algorithm, right? But so I'm just taking I'm just taking a few minutes to make you understand few concepts, then we'll jump to the coding part, don't worry, right? So suppose if you have a tree like this, so A is the root node, this is the left child pointing towards this node, the right child pointing towards this node. 2, further it doesn't have any child, and sorry, B, and then C. Now the B and C are not having any further child, right? So they don't have any left and right connections, right? So a tree can be simply represented by this, like this, right? And this is, you can say, a binary tree also, right? Right. So A has two pointer, left pointer and right pointer, right? Right. So left pointer points to B, right pointer points to C, and the left and right pointer of the B and C are null, and the same goes with the C also, right? These are null, right? So right, because B and C contains both null pointer on both sides, right? Both left and right part, right? Hopefully you got this. So these are the basic structure we have seen, right? Just a second. Okay. So now, like you, I've already told you that what are the level, everything. I guess I think I have told you already, and I have already told you about the kind of, you can say, types of trees also. So now let's jump to the part how to implement the tree, right? It's very interesting. Okay. So if you have to implement the binary tree, you can simply implement with the help of pointers, right? Pointers play a quite important role, right? I am using the concepts of C, right? We can easily implement the C program, the tree with the C program, right? But before the implementing the C program, we need to understand few things, right? Right. Tree, we can represent a tree by the root pointer, right? So I can simply write structure is what in the C program, structure is what collection of data, different kinds of data you can store in the structure, right? So I've taken a structure as named as node. So I'm making a node of a tree, right? I'm making a node of a tree, right? And I'm taking two things in this int data, right? And I'm making a two node type pointer, struct node, strike left, and star right. You can take any name, you can take value, you can take any lr, any name you want to have, right? So what I've done, I'm telling you that you have taken two value to you are just forming a node, and what you are doing currently over here, let me tell you, you're just forming a node, which I have told you just now, right? You are just forming a node, right? So it has the data itself here, data, it has left pointer and the right pointer. Basically what they will do, you already know that they will just simply point the left child and right child, and data is the values which will be stored. So this we are just forming a node. So whenever you are forming a node, the right, you will be like, you whenever you are forming the node, you can just simply create by this. So let's make a quick program of binary tree, and we will try to like make a small program of how to enter the value in the left child, how to enter the value in the right child, right? And then we can also see the output also, don't worry. I'll use today C++, Java, because like earlier, like few students were having the queries, like earlier the few students were having the queries that how, sir, can we implement in Java also, can we implement C++ also, can we implement in C also. So these are the few questions, queries raised by like you, some of your students yesterday. So to solve this doubt and to solve this issue, definitely I'll be considering all those languages today also, right? So I'll make the making this program, tree program, very basic program of tree in the C, right? So let's make this program the C language, right? So what I'm doing this, what program I'm making now, I'm just implementing a binary tree with the help of C program, right? So let's see. I've taken a basic compiler, Dev C++, you must have seen. You can use any compiler, whatever you want, code block, right? Notepad++, VS Code, whatever you want. Let's start a new file, right? So let's start. Right? Let me increase the size of this tag font weight. Wait, wait. I'm just trying to change the size of. So let's start. So I've taken a library std.h for performing a basic, right, to perform the basic input output operation. Then struct node. I'm forming a node as I told you earlier, right? So I'm declaring a structure named as node, right? I'm taking a data variable where it is of integer type, and I'm also taking to node. See, whenever you declare integer pointer, the pointer are of integer types, and here you are declaring the pointer of node types. So that's why I'm declaring struct node left, and you can say right. So till now, what I've done, I have just formed a node, right? We have just declared in data. We have just declared node struct node. We have taken left pointer, and I've also taken a right pointer, right? Right. So I've taken a left pointer. I've taken a right pointer, right? Now let's move further to the main function. Right. So in the main function, what we will see, we will create a root node also. Right. After creating root node also in the root node, then we will create the left and child. Then we link the left and child to the node, and that's how we will move further. Right. So I've just created a node. Then we will create a root node also. Right. And then what I will do, I will just link the left and the right node with the root node. Right. So this is the main function which I've taken. Let's say I declare, let me declare a root node struct node of, I have already declared the structure above of the struct, right? So I've already declared structure above the root node, about the node structure I've already declared. Now using this structure I can make any node, right? So I have taken a root node, right? And let's create, let's make a function, let's say generate, any name you can say, or you can say, yeah, generate, you can take any function. So I'm calling a function, I'm calling a function named as generate. So generate node, what it will do, it will generate, let's say function define function, it will, what it will do, it will help us to generate any node and to connect to the further nodes, right? So this is the what I'm doing here. I'm just creating a root node, right? And now let me declare a function also. Let me make the program first. Then once I make the program, I'll explain you each and every step. Don't worry, right? So keep that what I'm doing currently, what basically we are doing. So the function they do this generate function will type return a node pointer, right? So that's why we have taken the return declared in the return type as struct node, and we have taken generate. We have given the name as generate. You can take any name, right? Here I am making a temporary node. Why I'm making temporary node? I'll tell you. Struct node, right? I am taking a data variable also. I'm declaring a data variable also in this function, right? In this function also I'm declaring a data node. Now what I'm doing, I make a temporary node. So one more thing, that whenever you are declaring a node, suppose you have made a node, अब आपने एक node बना ली. Now what you have to do, अब आप उसको node को memory space allocate करना है. That is dynamically. What जितना भी size उसको required होगा, whatever size the node will be required, you have to allot them, and you can simply allot the node by the malloc function in the C. Struct node. I'm simply, what I'm doing, I'm simply allocating the size to the temporary node which we have made. Please remember. Right. So what I've done, I've written the malloc as the memory allocation size of what size it should return. Whatever size of the node is there, you have to return, right? You have to allocate. The malloc is memory allocation, a size of to find a size, and the size of will find the size of the node, and it will return. It will allocate the memory according to the size of the node, right? Right. So we have just allocated the size, right? Now let me make few choices, right? Let me make few choices, that how we can make how we can ask the user to enter the value, to enter the node, right? So let me ask with the user whether what does he want. He want to enter a new node, he want to exit, or he want to, suppose you are a user. Now you want to, like, you want to create a node, right? You want to basically you want to exit, and whatever you want to do, you can simply do like this, like. So I'm asking the user, I'm showing the options, like I'm creating various option now, that what a user can do, right? So I'm creating various option. So this is basic program which we are making to implement a binary tree using C, right? So I'm writing this, press 0 to exit, right? Let's I've given 0 to exit, 1 to, right? And similarly, this can also be done by the switch case also, but there are no such more choices, so we can simply do it with the if else also. There's no need to switch in case. If you wish, you can simply use. I'm taking your input from the right value, right? And I'm just making this is, let's say choice is a variable which user is inserting the value, right? Clear? So till now what I've done, I'm just asking user to create, to enter his choice. According to this we can perform any operation, right? So I've just given the input to the user, right? So I've taken this, like. Now just a second, just wait a second. So we have done this also, right? Now let the user, if the let us decide what we should perform, the what operation we should perform on the basis of the choice. आपने जो यूजर जो चॉइस है उसमें देखता है, अगर चॉइस मान लो 0 के बराबर हुई, let's say the choice is equal to, sorry I've given the wrong spelling of choice, right? So suppose choice is 0, then I can say simply, I can simply return, right? Simply return 0 and the program execution will stop, right? If it is not the case, then I'll do else. What I'll do, use else. I will use else. So suppose the choice user ने enter करी और choice is equal to 0, choice is not there. The choice 1 and 2 which we have selected, I guess, yes, 0 and 1 we have selected. 0 पे हमने already show कर दिया कि हम लोग exit कर जाएंगे. That's why अगर choice 0 के बराबर है तो हम यहीं से return कर देंगे. If it is not the case, what I will do, I will just ask the user. अगर node create करनी है, if you have to create a node, you have to generate a new node. What I need to enter, what I want, what do I want to user to do? I will simply ask user to enter the node, right? Enter the data basically. So I simply say, right? right? So what I've asked done till now, what I've done, I have made a node. I have made a generate function which will return a node, right? Generate function just to return a node. That's why struct node thumbs up. So see, I'm creating a root node, struct node root. Similarly, this generate my function is also return a node, right? That's why return type I've taken the return type like this. I have created a temporary node, allocated the memory. I've taken these. Now I'm asking the user if he wants to enter a new, even if he wants to create a new node, or he just want to exit. Just I've given a choice to him. Now on the basis of choice, I'm using the conditional statement, right? I'm performing this, right? Right. So now I've taken as I've taken, I asked the user, right? So now the data variable which we have taken, now we can just simply insert the data in this scanf data, right? Right. Okay. I think I like maintaining this size also, editor option, font, right? I think now it is properly visible to everyone. I think earlier it was not visible. That's why I've changed the size of the. Right. So now what I've done, I've taken a else and the else option. In else option, what I'm doing, I'm just asking user to insert the data, right? I'm just asking user to insert the data, right? So now let me tell you, we have just see we have just seen that on the basis of choice we have just created an else option. I can simply taken a data. Now in pointer, whenever you access the member of a structure, whenever you access the member of a structure through pointer, then you simply use arrow, right? Simply use arrow. So temp data is equal to data. temporary node temporary node is a structure whose member is a data c, एंड उस डेटा मेंबर में अगर आपको कोई वैल्यू डालनी है, जो आपने डेटा में डाली ना, यहाँ पे वैल्यू डाली, दैट यू कैन सिंपली पुट बाय दिस डेटा फ्रॉम वेयर, दिस डेटा इज कमिंग फ्रॉम दिस, ये नोड है, एंड नोड का स्ट्रक्चर क्या है, डेटा, दो पार्ट है, एक डेटा वेरिएबल है जहां पे वैल्यू डालोगे, और मैं सिंपली यहाँ पे भी एक इंटीजर वेरिएबल, आई हैव टेकन इंटीजर वैल्यू डेटा, जहां से मैं इस टेम्परेरी नोड के डेटा मेंबर में वैल्यू दे रहा हूँ, डेटा जो मैंने यूजर से जस्ट इनपुट लिया है. व्हाई आई एम पुटिंग द डेटा, बिकॉज यूज अगर मेरे को कोई भी नोड जनरेट करनी है, न्यू नोड, तो उसको वैल्यू देनी पड़ेगी, राइट? वैल्यू देनी पड़ेगी, स्टोरेज हमने ऑलरेडी दे दिया, राइट? नाउ वैल्यू, कोई भी नोड बनाने के लिए वी हैव टू फॉलो थ्री थिंग्स. फर्स्ट, नोड बनाओ, नोड बनाने के बाद मेमोरी एलोकेट करो, देन उसको डेटा वैल्यू दो, then create the link for the left child and the right child. These are the three basic steps you need to consider in your mind जब भी आप कोई ट्री बना रहे हो, राइट? सो मैंने यहाँ पे क्या करा, मैंने एक टेम्परेरी डेटा, टेम्प के नोड के डेटा को वैल्यू दे दी मैंने यहाँ पे, राइट? नाउ मैं यूज नाउ लेट्स आस्क द यूजर दैट enter the value in the left child, right? So as I ask the user to enter the value for the left child, right? So what I'm doing, I'm just asking the user to enter the value the right child, right? Enter the sorry, the left child, right? Clear? और इसको नाम से पुकार देख देते हैं, यहाँ पे जो हमने डेटा दिया ना वैल्यू, उसके वैल्यू से देख लेते हैं हम लोग डेटा, जस्ट डेटा मेंबर अभी हमने डेटा वैल्यू वाली मेंबर लिया, उसकी वैल्यू हम देख लेते हैं कि इस वैल्यू का लेफ्ट चाइल्ड करो, वैल्यू एंटर करो इस वैल्यू के लिए, ये डेटा जो आपने फॉर एग्जांपल एंटर किया उसका लेफ्ट चाइल्ड का वैल्यू एंटर करो, राइट? राइट. सो नाउ उसके लिए हम वापस क्या करेंगे, टैम्प का कौन सा पॉइंटर एक्सेस कर रहे हैं हम लोग, एक्सेस कर रहे हैं लेफ्ट चाइल्ड को. सो आई विल सिंपली temp left equals to generate. I will call this generate function here. so that I can simply right, I can simply generate the left child for this, right? Same again as goes to this, right? So I'm simply writing this key, enter the value for the right child of this, enter the value for the right child of this, right? Because यहाँ पे we have created the node, right? यहाँ पे we have created the node. uh, okay, Avinash sir, please make the screens full. Wait, I think now screen is visible to everyone, I guess. Can you see the code size now, everyone? Can you see the full size now, everyone? I believe everyone can see the full size now. I'm continuing now, right? If you are not able to see, please let me know, right? Can you see the code? Still you cannot see the code? I think it's clearly visible, I guess. Please check everyone whether you are now able to see properly or not. Please wait just a little bit lag. Just a wait. Are you able to see the full screen now? If you are able to see the screen, if you are able to see the code completely, please ping yes. Wait. You are already in full screen, I guess. You're already in a full screen, right? So let's continue where we were earlier, right? So now what I was doing, we were just calling the generate function to generate the uh, that so temporary. So what I'm doing, I'm just calling the generate function on the basis of this, right? So I'm creating the left child and I'm creating the right child. Entering the left child, I'm entering the right child, right? I'm entering the left child, I'm entering the right child, right? What I've done now, what I'll do, I've just created the left and I will simply return the temporary node, right? So now let's start with this again, that we have taken again. Let me explain this program completely so that you can easily understand. Now I've taken a header file. Please focus again. We have taken we have declared a structure named as node, right? We have declared structure named as node. There is two part: data and the left node and the right node, right? Let me check my screen. Let me again check whether my screen is on full or not. Right? Wait. So I think so I've taken a left node, I've taken a right node, right? I've taken a main node, right? I've taken struct node that is root node. I have generate a root node also, right? I've closed this. I've created a function named as generate, which will return a node. I've taken a temporary node also, and then I've declared a data variable. Then I've allocated the memory dynamically to this temporary node using the malloc memory allocation by finding the size of the node, right? And then I've given two options to the user that if he wants to exit, he can straight away exit by pressing 0, right? And if you want to create a new node, you can simply press 1, right? So then he will enter his choice. That percentage, then we have taken a variable. If choice is equal to 0, then we have simply written as 0. We have simply written to the program, right? And if choice is not equal to 0, then we'll come jump to the else part. We'll jump to the else part. And what is the else part? That we will ask the user to enter the data, right? And then ask you to scanf, and we will take the data from the scanf function. Then when the temporary node accessing node member of the node through the pointer, we use the this arrow sign, right? So in the temporary data member of the temporary node, we just inserting the data value, any value. Then we are asking the user to enter the left child of this value, the data which is inserted of this right child. So what I'm doing, I'm simply creating a function named as using this generate. I'm simply creating the right. I'm also creating the right child for the same data value, right? Right. So I have created this temp on it. Wait. I have mistake. I've done a mistake. Right equals to generate because we are creating a right node, right? Okay. And then we are returning the tab, right? Let me see. Let us see. Just a warning. Where let me tell you. Okay. Let me like remove this warning. Wait, just a second. Okay. Let's close this. So I've taken a standard function, a standard file, a data variable, struct node, node pointer root, then it. Actually, we just forgot to we forgot to mention a semicolon here, not here, because we are closing a structure. Then we will always we need to mention the semicolon over here. Then int main, we have taken the variable over here, return 0. We have also taken generate function, right? Let's see. It is giving a warning. Make a point assignment makes pointer from the integer without a cast. Let me see. Just a second. Let me close this code. Just a second. Okay, give me a second. I'll fix this code because it will take more time. So let me just switch to the other part. Definitely, I'll just give me 2 minutes. I'll remove all the warnings it is giving. Right. Meanwhile, let's move the further part. So now consider let's consider. Give me just 2 minutes. I'll remove all those error. Right. While I get time. So without wasting any more time, let's jump into the operations of the till. Right. We can say BST. The first operation which we will see is the searching. The other operation is the traversing. So searching means suppose you have given with the binary BST 18, 14, 23, 9, 15, 27. Now suppose a new node comes, right? And I have insertion is one of the also operation, right? Suppose a new node comes and the new node is insertion, right? And the new node is insertion, right? New node insertion. So suppose if I'm inserting a new node named as 9, sorry, 7. So what I'll do, how this insertion operation takes place, how does this take place? So 7, I will compare this with first with the root node. If it is smaller, then I'll go again to the left subtree, and again I'll go to the left subtree. I'll perform this operation until and unless I don't find a perfect position for this, right? Now think, if I have to insert 25, how will I do? Just give it a second to you. If I have to insert a value 25, how will you do? Just give it a thought. If you have to do like this, just give it a thought. How will you do this? Any idea that how we can, if suppose if I have to perform, can you tell me where it will come in the comment? Can you tell me where the 25 will come in the comment? Can you comment where it will come? Any idea, everyone? Okay. Can anyone tell me in the comment where this 25 node will come? Any ideas, everyone? Right? Any idea? Okay, so 24, 25 will come at here. You compare it with the loop root 18, it is greater than 18. It is greater than the 23 but smaller than 27. So it will come left of the 27. Now, if I last question, if it comes like 19, please tell me in the comment where it will come. That 19 node, if I insert the 19 node, where it will come. Please tell me. Can anyone tell me where it will come in the comment? 27, left of 23. You have say the yes, you can say you are saying the 19 will come at left of 23. Very good, right? So Tilak has said given the right answer, right? Okay, sir. Okay, so some of you have given the right answer also, right? No issue. Okay, now let's move to the further operation also. The further operation is very important. With the deletion. The deletion is quite tricky, and you can say in the BST. How does deletion take place? It has three cases while to consider. So, but before deletion, I have to tell you traversing also, because in the third case the traversing will also be done, and the traversing also I will take a very shortcut, right? So let me tell you what is traversing is used. Traversing basically, as we know, is all about visiting all the nodes in a tree. So for example, I have taken a node A, right? So traversing in binary search tree is done in three ways. First one is the pre-order. So how does the pre-order take place? It's simply like root, first we visit root node, then left, then right node. In the post order, we visit left, right, and root node. In the in order, visit left, root, right. Left, root, and right, right? So what is the order? Pre-order is root, left, right, right. Post order is left, right, root, and the in order is left, root, right. So now consider the term pre-order. As you are seeing, pre means early, so the root is coming first. Post means after, so the root is coming at last. So and in means in order means in means between. So root is coming between. So in the pre-order, you will visit root node first, then left, then right. In the post order, you will visit left, right, and the root node. And the in order, you will visit left, root, and right. Now one more thing, let me tell you. First, find the in order pre-order of this. So how will you find a pre-order? First of all, root will come a root left node. B is itself a root. You can say root left, again left of this D, root left. This is left, again this is left, root. And why it is B is coming? Because B is also a root. You can say B is also a parent, right? Then root left and right, then E, again root left part has come, and then right. Right, C is also a root. Root left, right is root. This is also root C, and then right is F part. This is the pre-order traversal of the tree given to us, right? So this is how I can simply find the pre-order. Don't worry, I'll tell you a shortcut trick also, by which you can quickly find the traversal, all these three traversal. But first of all, I'm telling you the conceptually, then definitely you can simply then you can simply find the traversal by the help of the trick which I'll tell you, right? So now, okay, okay. Now let me tell you one thing. Uh, Again, let's jump to the other part. That is post order. So post order means left, right, and root. Now considering this, what was it? Traversal, traversal, A, B, D, E, C, F. And this was the pre-order. Now consider post order. Post order, what we do? We find the left, right root. Left, this is the root. Left is this. Then this is the left. So I'll start with D. Left, right, root B. Left, right now. Left is not there. Left is not there. Right, root. Left has done. Right has done. Then root. This is the part. This is the post order. You can say. So this is the post order we have seen, just seen, right? Now go to the last part. That is in order. In order, how will you see? You'll find the, it says left. So left A, root of A is B, and left of B is D. So D, left, root, sorry, left, right, left, root, right, left, root, right, right means left, root, right. So this is what in order, which we have seen, right? Clear? This is the in order we have seen. Any doubt in this? This is the in order, pre-order, post-order. I have told you. Now, this is a like a basic method of finding all those things, right? But suppose if you get a complex tree, how will you find this, right? How will you find this? And then comes like the trick which you can easily use, right? So suppose that now let me tell you the trick you can easily use to like find quickly, right? So now सपोज यहाँ पे हमको मेरे को यहाँ पे फाइंड आउट करना है in order to order. So what I'll do, a simple trick, remember, just make a path like this, draw a path like this. Some of you might be knowing this trick also, but and we keep one thing, if C doesn't have the left side, but still make a space for him, still make a space for a child, so that it will be better for you, right? Now for finding the pre-order, just mark the left side arrow for each node. Mark the pre-order, right? So I will traverse from here to, I will traverse like this from start to end. I will traverse like this. So whatever arrow I'm crossing, I will write those names. Please focus, everyone. See, I've started from here to here, right? So first, what I'm encountering A. So left arrow will work for pre-order. Left arrow will work for pre-order. So A will come, then B, then D, then I'm going E, right? Right. Let me take a color for this. So I'm getting A, then I'm getting B, then I'm D, then I'm E, right? Then I'm getting C, and then last I'm getting F, or all the nodes are finished. This is what? This is the basic trick for finding pre-order traversing of any tree. By this shortcut, you can easily find. Some of you might have been knowing the same concept, but if anyone doesn't know, that's a very quite important trick which you can use for finding, right? Finding what? A pre-order traversing, right? The left arrow, keep in mind, the left arrow you have to use the left arrow. You have to use the left arrow, right? Clear? Hopefully it is clear to everyone, right? Hopefully it is clear to everyone. Any doubt? You can ask me in the last half an hour. But still, I believe this is a very I believe this is a very important part. So let me tell you the again the other one. The other one is the first we have seen the pre-order. Now let's go to the post-order part, right? So I believe pre-order you don't have any issue in this trick. Hope everyone has understood the same, right? Just a second. Let me have a water break. Right? Okay. So let me tell you the other one. Now let's come to the post order. For the post order part, what you need to do is to right arrow, right arrow, right arrow. Again same method. I'll start with the A. जैसे ही जो मेरा फर्स्ट एनकाउंटर होगा एरो, फर्स्ट एनकाउंटर किसका एरो हुआ है? डी का, मैंने डी लिख लिया, राइट? व्हाट आई एम वी आर वर्किंग ऑन पोस्ट ऑर्डर, और पोस्ट ऑर्डर के लिए राइट एरो, देन ई, देन बी, then F, then C, and then A. This is the traversal for post order with the help of right arrow, right? Right. Hopefully this is clear to everyone. I think anyone don't have any issue. Clear? Hopefully it is clear to everyone. I think there should not be an issue. We have simply done what we have done. We have just checked. Okay, now let's come to the last part. the in order. For in order, what you need to do, you need to make down arrow like this one, this one, this one, this one, right? Now let's consider again, going from starting from this. Which point I'm getting encountering the D node first, then B, then E, then A, then C, then F, right? So D, B, E, A, C, F. This is what in order. This is the best trick which you can finding anytime. You can simply find the in order and post order, right? Any doubt? Now for practicing, uh, suppose if I take a complex tree, I'm giving a question for the practice also. You can practice whenever you get time, and you can ask me whenever. Let's take a little bit difficult question. Please take a screenshot of this question. What you have to do, you have to simply find. You have to simply find. You have to simply find. What you have to do, you have to simply find whether whether like how you can apply the trick. Right? I've just give you a question of the same, right? Right? Please take a screenshot of the same so that we can answer it. And I can also now once we have seen this, now let's come to the last operation, that is deletion. Now let's come to the more point, the deletion. So deletion has three cases, and deletion is a quite tricky in few of the cases in the binary search tree, you can say. So suppose we are given with the node, right? This is the BST we are given with, right? Suppose I have to perform a deletion. So deletion can be performed in three cases. First one, suppose the node which you want to delete, अगर आपको जो node delete करनी है, that is a leaf node. That is a leaf node. 19, I have to delete 19. अगर first case, if the leaf node, if leaf node directly remove करनी है, you can simply straight away cut the leaf node, right? Simply straight away cut the leaf node. Just you have cut, right? This is how you can do, and you simply remove the leaf node. No issue in this, right? No issue in this. Now, suppose the second case comes. Now you have to remove that leaf, which is one child. which is having a one child. Now suppose you want to remove a node which has one child, right? How will you do? Suppose I have to remove 14. I have to remove 14, right? So I have to remove 14. I'm sorry, I have to remove 13. 13 has one child, है ना? 13 has one child, right? So I have to remove 13 here. 9. Yeah, 19 was the point. So I have to remove 13. So what I'll do? I will first replace this 13 with his child node. With his child node, right? Sorry, I have to sorry, just I have to remove a node which has one child. So 18, I would say 18 will be the example. So 18 is the node which has only one child. So what I'll do, I'll just first replace this node. I'll just swap the value of this node. I just swap the value of this node. So 21 will come here, 18 will come here, right? What change will come now? What change will come here? So 21 will be there and 18 will come. And now since 18 is a leaf node, so now since 18 is a leaf node, we can easily remove. Leaf node we can easily remove. So leaf node is done. Leaf node is removed, right? Right. So now considering the third case, a child, a node having two nodes. Now I have to delete a node having two nodes, right? Now I have to delete a node having two nodes, right? Clear? So any idea how will I do? Right. So now see, now let's see how we can how we can delete a node having two child, right? So suppose I have to delete a 13. I have to delete a node 13, let's say. I have to delete a node 13, let's say. So now if I have to delete a node 13, then what I'll do, 13, what I'll do, I'll just find its in order successive succession. So I will just find its in order succession. In order succession means successor means just I will find its in order, then the next node 213 I will swap with this. How? Let's say I am finding the in order of this 9, 13, 14, 15, 18, 19 and 21. This is what in order of this. सो सपोज अगेन आई एम टेलिंग यू, जब भी आपको कोई ऐसी नोट डिलीट करनी है जिसका दो चाइल्ड हो, तो आप उसका पहले इन ऑर्डर और इन ऑर्डर वो निकालोगे ट्रैवर्सिंग, एंड देन जिस भी नोट को डिलीट करना है उसका जस्ट नेक्स्ट वाला नोड वैल्यू देखोगे। 13 का जस्ट नेक्स्ट नोड क्या है, क्या फाइंड आउट करते हैं हम लोग, वी जस्ट फाइंड इन ऑर्डर सक्सेसर। सो इन ऑर्डर सक्सेसर ऑफ 13 इज 14 एंड इन दोनों को स्वैप कर देंगे, राइट? तो 13 विल बी स्वैप विद द 14, राइट? 13 will come here. So 13, 14 are swapped. 13, 14 are swapped. Then we can easily remove the node 13. So 13 can be removed. Hence, we are able to swap. Hence, we are able to swap. Right? These are the few three cases which I mentioned you. And deletion, I told you, a little bit tricky, but not that as difficult as we think. So we have done the insertion, we have done the traversing, we have done the deletion also. Now last, let me find the, let me tell you the searching operation. Sorry, last let me tell you the searching operation which we can easily find, right? Hopefully it is clear to everyone. Hopefully it is clear to everyone, I guess, right? Okay, just give me a second so that I can take a water break. Give me a sec, give me a sec. Now come to the next part, last part, that is searching. We are finishing it, then we will go to the, we will also cover the concept today, that is hashing and the hash map, basically mapping concept basically. Sorry. So suppose we are given with a BST, and now I'm writing A, B, C, D, E, and F. Sorry, I've given the wrong values actually. So suppose I have to find any value, then this is a binary search tree we are given, right? This is the binary search tree which we are given with, and suppose I have to find the value 16. So what I'll do, what will be the procedure? If I have to find value 16 is, if I have to find value 16 is not there. So first I will compare to the root, right? I will compare to the root. If it is the root itself, then I will return the root. If it is not the root, then I'll compare the value with the root node. If it is greater than the root node, I'll go to the right subtree. It is smaller than the root node, I'll go to the left subtree. So here in this case, the 16 is greater than the root node, 16 is greater than the 10. So what I'll do, I'll go to the right subtree, I'll search, and then I'll again compare with each and every node. If the value is greater than the every node, if the value is greater than the you can say current node, you will go to the right subtree. Again I'll go to the right subtree, so it is greater than the 15, and then again I'll check if it is smaller than or greater than. Now in this case 16 is smaller than 17, and I'll go to the left subtree, and here I find the my node. So this is how the searching algorithm takes place, right? So this is what, this is what we have done with, right? We're done with the operations, right? So now I already told you I've already told you about each and everything. I was searching like that tree operations. I will also implement the tree operations. I will also implement the tree operations. And as we are like very as we are like very as we don't have so much time, so we will also move to the hashing, and that is mapping concepts also today, right? I believe tree, what the tree we have covered, we have covered BST, we have covered the operations like of BST, like searching, insertion, deletion, traversing as well. And we will also see, let me tell also tell you the AVL also, the balance binary stress binary stress tree, right? Strictly right. Okay, let's fix this code also. Actually, I didn't take so much time at that time. Let me again, give me 2 minutes so that I can fix this code, because I need some time. I hope you understand. Okay, okay, now I got in data struct node. Yes, I've taken a pointer left, left, and then right, and this is also right. It doesn't put any effect, but strict. I can check. Then I've taken that struct node generate. Let me see if you have made a any mistake in using I've done made a create generate name function. Then I've created temporary node. Yes, I've also taken two variable choice and data. Yes, yes. Now temporary node I've taken a temporary node, right? Okay, let me did choice. So press one for creating new node. Yes, and choice. Now I'm asking a user to enter the choice. No, here is a mistake. I have to return null, because return zero will indicate what mistake I was making, because return zero will make the program indicate the successful. So what I'll do, I have to make return null here, and if it is right, then what I'll do here, I need to make the temporary node. Now I got the mistake. What I was doing, it is right. Struct node. Uh, See, earlier I was using the malloc, and the malloc function support comes from the std standard library. That's why it was showing error to us. Then again we have taken this scan of data, temporary data. Now I think everyone thing is right for us. I believe data we have written and data. Then I've taken the left side. Yes. Now I think everything is right. Okay, the one more extra packet is there. Rest is fine. Yes, we got the output. See, we are getting two options. We are getting two options. Press 0 to exit. Press 1 for getting no node. Let me tell you. Let me press 1. Enter the data. Let's say I enter 30. Again, enter the left side of 30. Right. Let me tell you 20. Enter the data. Let's say 15. Enter the right side of new. Enter press for create. Right. Enter the left side of 15. Right. Okay, press 0 to press 1 to right. Now I press 0. Wait. Right. So this is how we can simply create the code, right? So now we have made a code. I have just made a code of implementing tree, and I have made a program, main program, to do the same, right? Clear? Okay. Now we are done with the tree part. Let's move to the next important part. And before this moving to the next part, let me implement some. So let's come to the hashing part. Now briefly explain. Let me explain you briefly about hashing. Once you are done with once you got the knowledge of hashing, then I will implement with the coding itself. Don't worry. So we need to understand the hashing before going to the mapping, because hashing and mapping are somewhat somewhere same. Suppose you are मतलब आपको सी की बुक एक आप पढ़ रहे हो, राइट? सपोज लेट्स से you are going through a book of सी की बुक पढ़ रहे हो. So how do you find the topic so quickly? Just because of the indexing of the book, just because of the indexing of the book. बिकॉज इट ईच हर एक इंडेक्स के साथ टॉपिक्स मैपिंग है, हर इंडेक्स का टॉपिक की मैपिंग है. फॉर एग्जांपल सी के टॉपिक पढ़ रहे हो, डेटा टाइप ऑपरेटर पॉइंटर्स, राइट? So you can say it is on page number 10, it is on page number 15, because you are given the index, right? You are given the index, right? So by the help of indexing, you can say by the help of mapping between the indexes and the topics, you are easily find the topics, you are quickly able to find the data. Same goes here also. Everywhere where there is a large amount of data, you use indexing, or you can say in hashing, to quickly retrieve the data, to quickly access the data. That is the main reason of using hashing, right? We can simply implement the hashing in the Java or other programming language with the help of Hashmap also, that we will see further. But what we need to know before that, how what is hashing basically? So hashing is basically what we are just mapping large amount of data into the right, large amount of data into a smaller table, or so you can say smaller index, with the help of hashing function, right? Right, hashing, you can also say that hashing algorithm and message digest function also, you can say whenever you are using some kind of encryption using the MD5. You have heard about MD and MD5, that also uses the hashing concept, right? Right. So it is, hashing is basically what you are mapping large value data into the key. So hashing works in the form of key value pair, key and the value pair form, right? So and hash function is what? Hash function is basically convert a hash key, right? Right. Right. A key to hash key, basically a normal index to basically you are given some indexes and you are mapping with the topics in the books. That basically is done by the hash function, right? And hash function basically generates the hash value, or hash, you can say. So suppose let's take a very basic example. I hope it is visible to everyone. Well, if it is not, I have already made it zoom out, zoom, right, zoom in, sorry. Right. So now I've taken now I've taken you can say slot, you can say a table which has 10 slots in which I can store the value. So slots are from 0 to 9, the size is 10, right? The size is 10, right? At each slot, at each position, I have to insert a value. At each slot, each slot, at each position, I have to insert a value. But which value to insert at which position in this table, that I have to decide with the help of hash function, right? So which value I have to insert in which slot, that I have to decide by the hash function now, right? So suppose I have given this these values, right? I'm given with this value, right? Right. So I'm given this value. You can see here. These are the values which I'm given with 26, 70, 18, 31, 54, 93. So these are the values which we are given with the hash, right? So now 26, 70, 18, 31, 54, 93, we are given with this value, right? And now we also understand one thing, that suppose if we you have to insert this value, we have to use this hash function. This is the hash function. So suppose, how will I do the hash function? Key value and the number of slots. So key value is 26. Key value is 26 and the number of slots are 10. So whenever I take 26 modules by 10, I'll get a 6. Then 70 next value, then 18, then 31, 54. So I'll got those value, hash value. So these are what's, these are just the keys. These are just the keys, and these are just the values. With the help hash function, I got the mapping of values and keys. So at Z6 position, the 26 value will be there. At 0 position, 70 value will be there. And the 8 position, the value 18 will be there. At the first position, first slot, the 31 will be there. And the fourth position, it will be there. Right? Right. So it will be done like this. Clear? So now let's jump to the main part. That is, now let's jump to the main part. That is, now let's jump to the main part. That is a key value pair, right? So again, now I can see, after performing the hashing function, we saw 70 is coming at 0 place, 31 value. So these are the keys and these are the values. How does, how does hashing works? Hashing works like this: key and value pair. Hashing works in key and value pair only, right? So hashing works in key and value pair only. So this is the, these are the keys and these are the values, right? Clear? Okay. So basically, what we see here is the hashing done with the help of hashing function, right? What we see is hashing done with the hash function. Now this is the hashing part which we have done. Now here comes the situation, suppose new value comes, that is 60, and 60 again taken modulus value of 10, then its key will be 0, but the 0 position already 60 is there, already 70 is there. At 0 position already 70 is there. Then this situation is called as collision. This situation is called as collision. And to remove the collision, to remove the collision or clash, we use a method that is called linear probing. So linear probing is a method, is a solution to resolve the collision between the values, right? You get over here, right? Because see, earlier key values are there. Suppose next value comes 16, and if I take 60 का अगर 60 का अगर मैं 10 से मॉडल्स लूंगा, तो जो पोजीशन मिलेगी स्टोर करने के लिए की, जो की मिलेगी 60 की 60 के लिए 0, बट 0 पे ऑलरेडी 70 है. So this situation is called as the clash, or you can say collision. And to remove this solution, what method we use is the linear probing. Linear probing is the method of solving this solution. Linear probing is the method for solving the problem of collision, right? Right. So this is what we are seeing. We are seeing this linear probing. And linear probing basically is used to remove. Now, what is the formula for linear probing? Is this: P equals to 1 plus P percent mod size table. Let me take an example. P is a probing. P is a probing example. For example, let's take an example. We are given with this values and the keys, right? Right. The values with the keys, and this is the values, and the keys and the values. Now suppose if I have to insert 40 in our collection, right? So 40 hash value of 40 is 0. P की वैल्यू क्या है 0. व्हाट डिड वैल्यू गेट p is 0. नाउ अगेन आप यूज करोगे लीनियर प्रॉब्लम. लीनियर प्रॉब्लम इज व्हाट p इक्वल टू p प्लस 1. p इक्वल टू p प्लस 1 मॉडुलस साइज. सबको पता है p की वैल्यू जो पुरानी वैल्यू है 0 यहां से मिली पहले वाली जिस पे कोलिजन आ रहा था, प्लस 1 कर दिया मॉडुलस 10. साइज 10 है ना, आपको क्या मिला 1. 1 पे भी अभी है, 1 पे भी आपको यू कैन सी 1 पे भी वैल्यू है 31. यू हैव ऑलरेडी हैव वैल्यू 131. तो व्हाट आई डू, I'll again फॉर्म प्रॉबिंग. p की वैल्यू 1 थी नई वाली, तो p1 फॉर्मूला क्या है p इक्वल्स टू p प्लस 1 मॉडुलस साइज. राइट. सो अगेन आई टुक द वैल्यू ऑफ p एज 1. why 1? बिकॉज यहां से हमको p की वैल्यू 1 मिली थी नई वैल्यू, पर 1 पे भी ऑक्यूपाइड है. तो मैंने क्या करा p इक्वल्स टू वापस से फॉर्मूला लगाया p प्लस 1 वाला. तो p की वैल्यू 1 है, 1 प्लस 1 मॉडुलस 10. क्या मिला 2 मॉडुलस 10 इज इक्वल टू 2. सो 2 कहां पे, अब जब 40 वैल्यू आई 40 वैल्यू कहां पे आ जाएगी 2 पे, ये रही. So we have solved the problem of hashing with the help of linear probing, right? We have solved the problem of linear, collision, you can say, with the help of probing, right? Right? Clear? Clear? Now let's go to the next part, the coding part, right? How to implement? Let's see how to implement this with the Java. So let's make a new file. Let's say Hashmap. Let's make a Hashmap, a new file, right? Let me get the font size also. So now like now we are now we will see the example of hash map, that is hashing, uh, that is mapping concepts. You also can also say, see students, mapping concepts are what? Mapping is what? Mapping large number of data into key. so that you can easily access, easily retrieve the large data, right? So this concept is not a mapping, it is what similar like hashing. And with the help of Hashmap, you can simply implement, with the help of Hashmap, we can simply implement the hashing, you can say, in the Java. So let's see an example in Java how to implement the same, right? Let me increase the font size if possible. Hopefully now the font is visible to everyone. So now let me tell you first of all a few things about Java implement. I need to tell you a few things before starting for the Java example. So we have just covered the hashing. Please focus everyone. It is very important. Hashing is map. You can say mapping is very important in the interview round as well. So I'm telling you the mapping. What basically see, right? So you use Java. Basically use Java map interface for the mapping part, right? Right, right. So basically the Java map interface is from the, you can say, Java collection framework, which basically provide the data structure function, this data structure functionality. How the map works, for example, you can say you have keys here, right? You say A, B, and C. These value and his values are PCE, PIT, and PU. So these are what keys and these are values. This is how a map works, right? Right. So we can access these values. We can access these values using these keys, right? We can access these values using these keys, right? Right. So you can say, so in the Java, we need to understand one thing. The map interface, basically, you need to remember the fact that the map interface gets has three things, right? What are three things he has? Basically, first one, the set of keys, the set of values, and the pair one, right? And the pair, right? The pair. What with pair? Set of key values, you can say. These are the three things a map interface in the Java has basically, right? Right, right. And I'm already, we cannot, we already know that map is an interface. We cannot make an objects, right? We can only implement, right? Right. We can have the classes who can implement, right? So basically, we will be using Hashmap class. Hashmap class you can easily use. So if you want to implement the functionality of hashing, or you can say mapping, right? Or other classes are also there. You can also see sometimes like the linked Hashmap was already there. Anum map, enumeration map is also there. You can also use those also. But for the time being, we are also only using map, right? So right. So map basically you need to understand. You already need to keep in mind the map is the main interface. Wait. Sorry, sorry. Map is the main interface, and you can say Hashmap is the class which implements it. So Hashmap implements map. Hashmap implements map. Hashmap implements map. This is how we do it. So that Hashmap implements map, right? Right. Now let's jump to the programming part also, right? we will see some methods also while working on the code also. We will see some methods, that what are the method. I'll tell you what are the methods which use, right? So let me tell you, let me import. Let's say we have taken a class hashmap also. So let me import java dot util dot map is the interface, right? The map is the interface, right? And we will also use a class, that is hashmap is the class which you will use, right? Or java, you can say, or util dot hash. Keep in mind the hash map, right? This is the hash map which you can use, and it is showing key. Kv means key and value, right? Sorry. So these are, map is the interface class. This is we have imported the interface also, and we have also imported the class as well, right? Now let me take a main class. Let's say hashmap is our main class. Hashmap the class which we have defined, and hashmap this class is the predefined, and which is there in the util sub package, right? So let's make a main function. We have taken a main function, that public static void main. Now we are creating. Now we will create. First we will create a map, right? So we will create a basically map using the hashmap class, using the hashmap class, right? So how will you use the map? Basically we are using the we will create a collection, basically a list, where we will maintain, the key value pair, right? So we are creating a map. How will you create this? So when we are creating a map, we need to consider two things. First one is the key, other one you can say value, or key or value, anything like you can say. So first I am taking a string, then integer, right? String class and the integer class I'm using here, and I am storing the values here. Numbers, I can say, you can say. So number, let me take you, so let values, it is values, right? New Hashmap, right? So I have just created a map, and object as values, right? Right. Okay. Now since we have created a map, now we will insert some elements in the map. See, in the map always we will insert the values in the form of key and value, the key and value, right? The key and value format, right? Clear? Just a second. So let me tell you how we'll insert the object name is value, symbol, object name is values, dot put. So you will use always put function, right? So first of all you have to enter the string key. You know the keys here, the key is string format and the values in integer format, right? Right. So I have taken a root. So let me take it as first, and the value, let's say 1. Let me copy this and paste this, right? So till now what I've done, I've used the hash map and map interface hash map class. I made a main method. I am creating a collection. Sorry, I am creating a map and map is always created with the help of two things, that is key and value. Key is a string format and value is integer. I have created an object named as values. With the help of values, I am using a put function. Put function, right? I'm using the put function. So put function is basically used to insert the value into the, right, where in the mapping, right? Key and value, to insert the key and value in the map, we use the put function. So first, and then is the third. So this is how I'm pushing the value, right? So I have pushed three values, so three key value pair in the map. So I pushed the three key value pair in the map. Clear? Hopefully it is clear to everyone. So till now what I've done, now let me print these values also. I have taken the, let's print the value also. Let's say the map, let me tell you, right? And wait. So I'm just showing the value to you, what we can use, right? Values. Here we are using values. So I'm just showing the values over here, right? I'm just showing over the values basically I'm just showing the these key and values over here. I'm just showing the map. So the map which I've created over here, I'm just showing the map. How? Because I've created a values object, and these are the values, right? Clear? Value should not be a right word because key and values are already there. Data, I can say data would be better. I can say data would be better, because see, you will get confused because value are already there, key and value pair. So just to avoid that confusion, we are just changing the object name. Any object name you can say PC, PID, whatever you want. You can take any, right? So now what I've done, I've just pushed three values in the map named as first, second, and third. Right? Okay, clear? So okay, that's what I've done till now. The first, second, third, and I've also I'm just shown we are just printing the value. We are just printing the value of map, whatever map we have created. Right? Clear? Now we want to access the key, right? So let me tell you on the comment itself. Here also let me tell you the comment itself so that you can easily understand in the future. What we are doing, we're just printing. You can comment, you can write in simple language, as simple as that, so that you can understand. See, whenever you will be working in the industry, there the lines of code will be so much, right? In the there the lines of code of the application or software on which you will be working will be in the lakhs. So for it is very important for each and everything, for each and every module, you can say you need to do the commenting is a good coding practice which you should always do, so that to increase the better readability of the code, right? So I'm just writing printing the map data, I can say. Let's say again, what I'm doing, let's say accessing the key. Now we will access the key of the map, right? Say how will access the key. Let's see how will access the key. We are just printing the key of the right. So it is very simple, right? Keys, right? Let's say keys are, and this plus is because we are separating the data, and data dot key set, this key set. So this key set, what with this key set function does, it accesses the key of a map. To access the key of a map, we use the data, we use the method called as key set. We use the put method to push the values in the map. If I have to only see the key set, if only key set, then I have to use key set method. The key set method basically what it does, it आपको बच्चों ये एक set return करेगा. उस set में ये इस पूरे set में basically आपकी keys ही होंगी, right? Clear? Now keys और सारे अभी हम लोग क्या कर रहे हैं, देखो हम लोग पूरा पहले we are first seeing the map completely, then we are seeing the key, and then we will see the values also, right? Now let me say accessing the values in the map. अब मैप की करते हैं, मतलब वो भी करते हैं, राइट? सो वही एस आउट टैप, सो यहाँ पे वो वैल्यूज भी कर देते हैं, राइट? सिंपल है. आपका ऑब्जेक्ट क्या है, मैप का ऑब्जेक्ट का नाम क्या है, डेटा डॉट values is the function. You can simply use values function, value method to find out the values in that. आप समझ में आया मैंने वैल्यूज क्यों नहीं ली, मैंने वैल्यूज इसने ली थी यहाँ पे ऑब्जेक्ट, बिकॉज आपको कंफ्यूजन नहीं हो, right? Otherwise you would have been writing over here values dot values, so that could have created a confusion amongst us that why we are taking values and values. So to avoid this, I changed the object name as data, right? Okay, great. So first हमने समझा कि first we saw hashing work, how hashing works, we have understood. Then we saw that we have to use in the, suppose if I have to implement the hashing in the map, with you can use the map interface and you can use the class hash map. Then you need to simply create. कभी भी कोई आप बनाते हो तो आपको पहले, सबसे पहले कल भी हमने देखा था, we also created queue list, we also created stack. So सबसे पहले you have to create a collection, a list के बाद you have to create an object, then you have to perform some operation with the help of methods you are given with, right? So now what you have done, written data values, right? Clear? Right. So this is how you have access the key data, like the keys and the values here, right? So this is how you have access the key and the value, right? Now suppose wait, You have to remove. Suppose you have to remove. So up now, if I have to delete the values, I'm writing deleting the values in the map. Let's say. So if I have to delete a value, we know the values are in form of integer. Values are in form of integer. Let's say int n is equal to data dot remove. In the remove, I have to pass the key. Now see, that is very important to understand. जब हमने की बनाई थी यहाँ पे, वी नीड टू अंडरस्टैंड, सॉरी, ये हमारा फर्स्ट था, ये सेकंड, ये थर्ड हमने जो बनाया था, एंड सो ऑन. यहाँ पे हमारी वैल्यू थी 1, 2 एंड 3, की एंड वैल्यूज, राइट. ये हमने अभी तक बनाया प्रोग्राम में. सो ये की एंड जो वैल्यू हमने बनाया एंड वैल्यूज हमने बनाया. नाउ सपोज इफ आई हैव टू रिमूव दिस वैल्यू, if I have to remove this value, right, so what I'll do, I have to access this by this key. I have to access this by the key. हम की के थ्रू ही एक्सेस करते हैं सारे डेटा को, वैल्यूज को जनरली, राइट. अगर कुछ भी ऑपरेशन परफॉर्म करना है, इफ आई हैव टू परफॉर्म एनी ऑपरेशन, सो सेम गोज हियर. यहाँ पे व्हाट आई एम डूइंग, आई एम जस्ट रिमूविंग द एंट्रीज, removing the values in the map. How will I do? So I'll simply write object name is data, then I'll use the remove method, and in the remove method I'll pass the key. So 2 is the key whose values are value to remove, whose the key is the value, sorry, key is the sorry, 2 is the key from which I want to remove. So that जो second वाला element है, second element वो remove हो जाएगा. We will see in the output also, don't worry. Now again let me again, मुझे उस पूरे map को print कराना है. So now again I'm printing the whole map. Now I'll MC data in map, you can say after deleting, right, clear. So now I will see this, or you can also say, which value you have removed, or you can also say this, or you can also say s out tab plus, you can write n, because n already we have taken, जो डेटा रिमूव करा वो n है, राइट, क्लियर. Let's run this code. It is split, it is, see, we have run the code. Run the code. See, हमारी वैल्यूज आ रही है, हमारी वैल्यूज. लेट मी again run this again so that you can easily understand. Now हमारा मैप आ गया, ये रहा मैप आ गया, थर्ड 3, फर्स्ट 1, सेकंड 2. दिस इज आवर मैप, दिस इज आवर कीज, थर्ड, फर्स्ट, सेकंड, दिस इज आवर वैल्यूज 3, 1, 2, right. These are map, this is our keys, these are values which we have printed, right. Right. So this is what the program which we have made till now. We have taken Hashmap, we have created a map, we have put 3 of the first, second, and third, right? Then we print the values in the key. Then we have accessing the values also with the help of data dot key set. Then we're accessing the value also, data dot value, right? Right. And we can also access the entries. We can also access the entries. Let me tell you one thing. Accessing the entries in the map. Well, इसको जो मैप के जो एंट्रीज है उसको एक्सेस कर सकते हैं, जितनी एंट्रीज आपने करी है. And you can simply write entries are, simply write numbers dot, sorry, data dot entry set, right? Data dot entry set, what it will help us to and to access the entries, जो मैप की जितनी भी एंट्रीज है, right? This is third. This is a map, keys, values, and entries are third equal to 3, first equal to 1, second equal to 1. This is our, right? We are also having some inversion, cannot even java dot length dot int value, because the return value of the java return map remove object is null. Okay, got the point. See now, see not, यहाँ पे लेट मी चेक यू दिस. हमने वहाँ पे मैप बनाया थर्ड फर्स्ट 1 2, राइट? सी मैप भी एक सेट है, इसलिए वो रैंडमली दिखा रहा है, बट वैल्यू से दिखाएगा. थर्ड आपको थर्ड पे मिल गया, फर्स्ट इज इक्वल टू फर्स्ट, सेकंड टू, राइट? यहाँ पे हमने क्या प्रिंट कर लिया, मैप का डेटा प्रिंट कर लिया. फिर हमने क्या करा, डेटा की सेट प्रिंट कर लिया. की सेट हमारा ये रहा, थर्ड फर्स्ट सेकंड. फिर हमारे वैल्यू प्रिंट हो गई, थर्ड 1 2, राइट? फिर हमने एंट्री सेट, एंट्री सेट मतलब क्या क्या एंट्री हमारी, थर्ड क्या 3 है, या हमने यहाँ पे सिखा दिया. देखो मैप और थर्ड वो एक ही बात है, एंट्रीज दिखाना. नाउ हमने देखा है, उसके बाद हमने क्या करा, डेटा रिमूव कर दिया, रिमूव करने के बाद वी कैन सी डिलीट करना. हमने डेटा वापस प्रिंट कराया, डेटा को मैंने प्रिंट कराया तो वापस यहाँ पे, ठीक है. डिलीशन के साथ कोई इशू आ रहा है, आई विल सी दैट. थर्ड फर्स्ट 1 2 रिमूव की टू, वेट, इसलिए नहीं काम कर रहा था क्योंकि सेकंड नहीं था. अब चल जाएगा. देखो यहाँ पे ये पहले एंट्री थी, जैसे हमने डिलीट ऑप्शन परफॉर्म करा, रिमूव ऑप्शन परफॉर्म करा, जो यहाँ पे हमने जैसे सही की डाली, पहले हम लोग की अलर्ट डाल रहे थे. तो एज सून एज आई पुट द राइट की, नाउ द थर्ड एंड फर्स्ट ही बचा है, राइट? दिस इज व्हाट वी हैव डन. क्लियर? सो दिस इज द प्रोग्राम व्हिच वी हैव मेड. This is the program which we have made for Hashmap using hash and key, right? Right? You can take a screenshot of this same also. Okay, now move to the last topic. As फटाफट से. Just a second. Now move to the last topic of today, that is greedy methods, right? So let's jump to the next last part of today's last part. Right. So greedy method. Let's point to the greedy method now. So basically, we need to understand what greedy method is. In now in so many applications, in so many algorithms, we see the greedy method, which is also quite important part, right? So greedy method basically approach for solving a problem by selecting the, suppose you have so many solutions, right? So at each step you see which solution is best for you. That is the concept you use for greedy method, right? So you can also say basically greedy method is an approach for solving a problem by selecting the best option available at that moment, at whatever moment you are, at whatever step you are. Whenever you are seeing the best solution at that moment or that step, you find this best solution, you just select it. It is not necessary कि जो आपने currently जो आपने step select किया कि वो आगे जाके best निकले, पर at current वो best है तो आप choose करते हो. This is what all about the greedy method, right? Right. क्योंकि आप current step पे जहां पे हो वहां पे if you are getting a best solution you will select this, but overall you might overall it might not be the best solution, but at the current step yes it is the best solution. This approach you consider as the greedy method, right? And one more thing, in the greedy method you cannot do the backtracking, you cannot do the backtrace. Suppose आपने कोई solution choose लिया, कोई path choose कर लिया, आपको लग रहा है ये path अभी optimum है, best choice है, right? You think that path is the best choice for us, but suppose you come ahead and the next steps you find it that this is not the best solution which we have chosen, but you cannot go back, right? You cannot go back, right? And because it works in top down approach, right? Right. So greedy method you can say may not produce sometimes the right solution for all the problems, right? Right. But it is used for choosing the local best choice. It is used for choosing the local best choice, right? Rather than the global best choice, right? So basically, let's see some example also. And what's like you should also know when should we use the greedy method, right? When algorithm is easy to use, algorithm is easy, not difficult, you can use the greedy method, right? Right. This algorithm, बट ग्रीडी की एक बात होती है, कई बार ग्रीडी अच्छा परफॉर्म कर सकता है और कई बार नहीं भी करता, राइट? और ड्रॉबैक क्या होता है कि ग्रीडी, और ड्रॉबैक इज दैट कि भाई इट इज नॉट कंपलसरी कि आपको ग्रीडी हमेशा बेस्ट रिजल्ट देगा, राइट? लेट मी टेल यू एग्जांपल. Suppose I have 20. A simple example, we are just seeing an simple example to understand the basics of greedy method, right? I'm simply taking an example. Suppose we are this step 20. So the problem is that I have to choose a path having the maximum weight. I have to choose a path having the maximum weight. First of all, we are at 20. We are starting with the first 20. The root node is starting 20. We don't know what is ahead of us. आगे हमारे क्या हमको नहीं पता. So now we are at the next level. I have to choose between 10 to and 12. आगे मुझे नहीं पता, आगे का स्टेप का मुझे नहीं पता. अभी मैं 10 या 12 पे हूँ, मुझे आगे का नहीं पता. I don't know what is there like further. So I'm just at the present step, and present step I have to choose the best solution out of these. So 20, and first I've selected 20, then I come to the next step. So after coming to the next step, I have to choose the best choice out of all present over here, or after all options present over here. So at the current I see 12 is the best choice for me, right? 12 is the best choice for me, right? So 12, I think 12 is the correct choice for us. So at present, so 12, the greedy algorithm will choose 12. The greedy algorithm will choose 12. So greedy algorithm will choose to 12. So 12. Then I took 20, then I 12. But when I reach to the next level, I think I get the next node as 2. So when I add 20 plus 12 plus 2 is what? 34. But now if I go like this, 20 But if I would have selected this 20 plus 10, let's say 20 plus 10 plus 18, it is 48. So overall, it is not the right solution, but at present, it was the right solution. So that's how basically greedy works. That is a very good example, a very easy example by which you can understand how the greedy works. Okay. Just give me 2 minutes break. I'm taking 2 minutes break. Just wait, hold for a 2 minutes. I'm having a small short break. Hello everyone, I'm back. So let's finish. Let's continue. Right. So I'm taking 2 minutes break. Right. How? Let's see. Okay. So this is the example, basic example we will see. I'm also writing the greedy algorithm. How? What is the greedy algorithm all about? Basically, right. So I have to write to begin with. First, you will find the solution set, right? And always in the greedy algorithm, you find the solution set, right? Right, which having solutions, which is empty, right? Right. Second step would be that at each step you can simply understand the algorithm. Also, it is not so difficult. An item, we at each step we add an item, right? So I can say each step an item is added to the solution set until we don't get a solution, right? Right. Suppose if the solution is feasible for us, right? So what I'll say, if the solution is feasible to us, then we can simply write, right? If the solution is feasible, then we have to keep the item in our solution, and if not, then else we can simply write, we just reject the item, you can say. right? So, and what are the things, right? This is the algorithm we have done with simply, right? A basic, very basic algorithm. What are the different type of greedy algorithms you can see? You can find selection sort. You can find minimum spanning tree. In minimum spanning tree, you can see Prims and Kruskal. You can also find Discustra, the shortest path finding. Discustra also you must have heard. Discustra algorithm. And why do we use Discustra? You must have all have seen to find the to find the shortest path, right? Right. One was the Huffman coding is also you can say Huffman coding also you can say you can use, and you can also use knapsack also, right? Knapsack problem. So these are the few things which you can consider for the uh, greedy algorithm exercise. Few others, right? Selection sort, you can say minimum spanning tree, discuss Huffman coding, knapsack problem. These are the few problems which you can consider for the greedy algorithm, right? These are the kind of greedy algorithm which you will encounter in the future, right? So this is basically what about today's session. Now we have the dedicated time for 20 to 30 minutes for your queries. So it's a suggestion, it's a request. If you can just ask your queries in the chat section, right? You can simply put your queries in the chat section, comment section, and then I'll start solving the queries, right? You can simply put your queries in the comment section. Please put. Any queries, guys? You can simply ask your queries in the comment section. Clear? Please ask your queries if you wish to ask. Any query, please put in comments. Students, if you have any query, please ask. Hello everyone, please suggest the time. Please suggest the queries. You can simply ask me the question, whatever you want. Anyone, please, if you are having any query, please ask. Hello, anyone. Hello, everyone. If you have any doubt, please ask. Hello everyone. If you have still any doubt, you can ask. I'm waiting, right? Hello. So, hello everyone. You can just simply ask your queries now. As I've been waiting for a long, please ask your queries. If you do have any query in the comment section, you can simply write. In the comment section, you can simply ask your queries, right? Right. You can ask your queries in the comment section. Don't We don't have any problem there, right? So simply you can ask your queries in the comment section, and I'm also telling you that tomorrow what topics we'll be covering tomorrow, because tomorrow also we have a very kind of last session and it is very important. We will conclude all the things, and we will be also discussing. You can also discussing more, like we will cover the topics as well. But tomorrow you can also discuss with the various aspects of learning data structures. What should be the roadmap of data structure, and what are the companies you can target with the data structures, and how should you prepare for data structure. That's also you can discuss tomorrow. So tomorrow will also be an important session which you will attending, right? So now tomorrow what we will be covering tomorrow, we will the topics which we will be covering tomorrow are, the topic which we will be covering tomorrow is, we will cover the graphs, that we'll covering graph traversing, and what are the various graph algorithms. We'll be discovering that, and we also see some, we'll be also seeing the intro part of dynamic programming also, right? The dynamic programming, you also know it's very quite important, quite like important role in today's like the major companies like the Amazon, Microsoft, right? These sort of companies require the dynamic programming, right? And we will also see some string manipulation. You also know that by the help of the string you can solve like so many problems, like, so once you are good with the string, trust me, you can solve so many problems in the string itself, right? So string is considered as a very important topic nowadays, because so many questions you can crack down with the help of string. And then we have some coding practices also. We have also having some discussion for DSL roadmap, and how to like how you can proceed with the data structure strategy, like which companies you can target with the data structure. That also we will see tomorrow. These are the tomorrow few things which we will be considering tomorrow, right? Now, if you have any doubt, you can simply ask me, right? right? You can simply ask a question if you wish, right? If you have any doubts, students, please you can ask me, right?
Arunji, we can close the meeting. Shivraj sir, you can end the live session also.
Thank you, sir. Thank you so much.